Welcome to the Visual Guide to Lockpicking. You are about to watch an instructional video that will explain how warded locks, pin tumbler locks, and wafer locks work and how to pick them. You can use this knowledge to bypass most modern locks that are deployed today. This video is based on the book Visual Guide to Lockpicking by Mark McLeod. You may find it very helpful to follow along or refer to it for more details in your continued studies. Chapter 1. Warded locks. How to identify them, how they work, and how to defeat them. First, let's look at how to identify a warded lock. These are some example keyholes you might be familiar with. They are usually found on warded locks. Today, warded locks can be found on cheaper padlocks, furniture, handcuffs, luggage, and many other low-security applications. When the keys are inserted into this type of lock, they will generally slide in and out with no resistance. Only when turning the key will you begin to feel any resistance. More importantly, there will be no pins or wafers when looking inside the keyhole. Now to get started, let's look at how a very simple lock design works. What you see is a deadbolt. This is the part that slides in and out of the door. This piece is the locking bolt. When it turns, it locks and unlocks the door. Finally, this is the keyhole where the key is inserted. This is a key for a warded lock. It can also open the simple lock that we just presented. At the tip of the key is the key's bit. It turns the locking bolt and unlocks the door. And these are protrusions. They do not unlock the door. They make it easier to turn the key, but are not essential. Keep in mind that any one or more of the protrusions could be the necessary bit, but you never know which one. Now let's make our simple lock into the warded lock. We simply achieve this by adding wards. The wards will allow the key with the right combination of protrusions to turn. Observe how the protrusions do not touch the wards. Today, warded locks are not nearly as common as their pin tumbler counterparts. They can, however, still be found everywhere, including your local hardware store. At first glance, they might even appear the same as pin tumbler padlocks, except for their lower price. One way to identify a warded padlock is by its distinctive keyhole. The keyhole is often made of a small, free-spinning disc with a jagged hole cut into it. This hole acts as a type of ward. Only a key with the appropriate profile and shape can pass through it. This padlock is constructed from many metal slabs stacked on top of each other and held in place with 4 rods. Most of the slabs simply provide 3 holes, 2 for the shackle and 1 for the key through which to pass. Some slabs, however, are specifically designed to serve special purposes. In this example, 2 of the slabs are special and provide the actual locking mechanism. These slabs act as wards. The key can easily pass through them as you insert it into the lock. But if you try to turn the key, the ward will prevent it from rotating, unless the key is cut thin enough at that point to rotate in the slot. For example, instead of a round keyway, some of the slabs have a flat slit that only allow the key to pass through but not turn. Each of them contains a piece of spring metal that rests in a notch in the shackle As long as this small piece of metal is in the notch, the shackle cannot be raised and will remain in the lock. The key or other tool simply bends this metal spring out of the way. Once it has cleared the notch, the shackle is free to leave the lock. It is important to note that this lock has two metal pieces locking the shackle in place, one on each side of the shackle. The lock will not open unless both metal pieces are moved out of the way at the same time. Now that you are familiar with the parts of the padlock, watch as the key moves in and frees the shackle. If the key is inserted partway into the lock, it may not be possible to turn it. Also notice that the two bits in contact with the spring are necessary for this lock to open. Often, warded locks only need one bit on a key, but in this case, two are needed. When the proper key is fully inserted and rotated, it will depress both metal pieces out of the notches in the shackle. The shackle then becomes free to pop out of the lock and rotate. Picking warded locks is relatively quite simple. All you need to do is move the locking bolt. Unfortunately, there will be wards in your way. The easy way to handle wards is by simply avoiding them. If your key doesn't have any metal protrusions that get in the way of wards, then the wards won't stop it from turning. Let's make a key with just a stem and a bit. The bit is used to turn the locking bolt. There are no protrusions on the stem to get in the way of the wards. This key would only have the bare minimum amount of metal to work with. Because of this, they are called skeleton keys. The best way to pick a warded lock is to have a collection of skeleton keys for the various types of warded locks. Try each key in your set on the lock. Insert the key as far as you can and attempt to turn it. If it doesn't work, try moving it in and out or around slightly. Then, move on to the next key. Depending on the type and shape of the warded lock, you will need an appropriate skeleton key. There are sets of common skeleton keys that locksmiths can use successfully in most situations. Often, nothing more than a simple bent wire or L-shaped tool is needed to manipulate the lock to open. Most handcuffs in use today also utilize the warded lock. These devices are specifically adapted to restrain physical movement. Those handcuffs that get regular use must be durable as well as cost-effective. In normal use, the wrist clasp can simply be closed and ratcheted shut. Professional handcuffs also allow for double locking. This allows them to prevent further tightening. This helps diminish undue and unintended bruising on those who must wear them. It also makes the cuffs harder to shim open or pick. The key must first be rotated in one direction and then the other to completely open the cuffs. The first turn disables the double locking mechanism. The second turn disengages the ratcheting mechanism and allows the cuff to swivel out of the wrist clasp. Sometimes you will find that producing an actual key is useful. One method of doing this is called impressioning. First, you must find a suitable blank to substitute for the key. Actual blanks for many warded locks are uncommon, since these locks are considered too cheap to make duplicate keys for. A key for a different lock of the same type is often a great item with which to start. An appropriate blank must fulfill the following requirements. It must comfortably fit into the keyhole, but not scrape along the sides of the keyway, and be strong enough to turn the locking bolt, and be able to handle a good amount of force without breaking or bending. It should also be able to withstand the stress of grinding and filing. Any long, flat piece of metal will often suffice. A jigsaw blade can easily fulfill these requirements. They come in a variety of sizes, are strong, cheap, and easy to find. If you choose to work with a blade, it is a good idea to be safe and grind or file down the teeth of the blade. For a tool, files work great, are inexpensive, and easy to find. A grinding wheel, however, will help your work proceed much quicker and easier. You can find these at most local hardware stores. A thinner cutting wheel will enable you to have more precise cuts. Once you have a good blank with which to start, you are ready to begin impressioning. You will need to put a coating on the blank that can easily be scratched off or marked on. A common way to achieve this coating is to hold the blank above a candle flame. The soot that rises in the smoke will cover the blank with a thin black coating, which can easily be scratched off. Another method is to use a candle to melt some wax and coat the blank with an even layer. Getting just the right thickness will take practice. You can also use a marker, tape, or anything else which will let you see the impression marks. When you are satisfied with your coating, you can begin impressioning. Insert the blank into the lock and rotate it with a good amount of torque in both directions. It should hit the wards inside the lock and not turn very far. Your goal is to have the wards mark the coating on your blank. It helps to jiggle the blank slightly to make the marks more visible. Now, gently pull the blade and observe the new markings left by the wards. You simply have to cut or grind away the portions of your blank that have marks on them. Ignore any long marks down the length of the blank that you made while inserting or removing it. Once you cut away the parts of the blank that are marked, your new key should open the lock. You may have to repeat this process with this key a few times if there are recessed wards you did not initially encounter. Chapter 2. Pin tumblers. Identifying them, how they work, plus the tools and skills you will need to defeat them. Pin tumblers can be found in many places, most commonly on house deadbolts, doorknobs, cabinets, padlocks, etc. They usually have pins visible in the keyway. These pins are often round and somewhat pointed at the end. The pins are spring-loaded and will spring back down when you push up on them. This is a plug. It is the part of the lock that the key turns. The hole that the key enters is called the keyway. The little protrusion in the keyway is called the side ward. These wards fit into the grooves along the side of the key, so only the proper type of key can enter. And this outer cylinder is called the hull or casing. This half remains in place and does not rotate. Inside you can see the pin columns. Although many pin tumblers have 5 pin stacks, the number may vary depending on the quality of the lock. Every pin column consists of 1 spring and 2 pins. The top pins are usually the same size and touch the springs and the bottom pins. The bottom pins vary in size to complement the shape of the key. They touch the top pins and rest on the keyway ward. The pins are pushed down by the springs. The ward prevents them from hitting the bottom of the keyway, from falling out, and also allows the key to slide under them. Before any key is inserted into the lock, the springs will push the top pins down. These pins will extend past the hull and into the plug. As these pins protrude into the holes in the plug, they will hold the plug in place and prevent it from rotating. The bottom pins can also stop the plug from turning if pushed up too far. As long as there is a pin that crosses the dividing line between the hull and the plug, the cylinder will be locked. When the correct key is inserted into the lock, the blade of the key raises the pins. The bottom pins will rest on the notches of the key. When the key notch is at the correct height, the separation between the top pin and the bottom pin will be at the same height as the separation of the hull and the plug. When this occurs at every pin column for the correct key, there are no pins blocking the shear line. There is now nothing to prevent the plug from rotating. The key can now turn and unlock the pin tumbler. There are standard sets of tools that many locksmiths and security professionals use. By no means are you limited to just these professional tools. You can find many common objects that will work just as well for you, if not better. The hook pick is the standard tool for lockpicking. With these hook picks, you can feel each individual pin and lift them without disturbing its neighbors, or you can rake across all the pins. The half diamond picks are easy to insert, remove, and rake over the pins. Use one of the appropriate size and shape so you can manipulate individual pins if needed, or easily rake over many pins if desired. The ball picks are very smooth for raking across pins and are especially useful for dealing with flat wafers. The double-sided picks are useful for double-sided locks, such as the double-sided wafer lock. We'll talk more about those later. Rakes of different shapes and sizes are often useful. Different tools work better for different locks. Lots of random household objects can be used. Use your imagination. The torque wrench is one of the most important tools. It is used not only to turn the plug, but also it is used to help you feel what is going on inside the lock. The smaller end is inserted into the keyhole, and you use the longer end to rotate the plug. Make sure you leave enough room in the keyway to insert your second tool. Keep in mind, even if you watch this movie and fully understand all of the concepts, you will still not necessarily be good at picking locks. There is no substitute for practice. Get yourself a variety of locks on which to practice. In order to successfully pick the pin tumbler lock, all you really need is a torque wrench and a hook pick. There are many methods you can use. We'll cover a few, plus some automatic tools. The torque wrench is inserted into the keyway and used to rotate the plug. Apply a continuous light turning pressure. The pick is used to manipulate the pins. Keep a slight turning pressure with your wrench while doing this. Raking is one of the easiest methods to learn, although it can be difficult to fully master. To rake successfully, you need to have just the right touch. This is something that can only be learned through practice. Raking is one of the fastest hand methods when it works. First, place a torque wrench in the keyway, leaving plenty of room to access the pins. Now, apply a gentle amount of turning force in the correct direction. It is very important to apply the appropriate amount of force. Usually beginners tend to push too hard. Often just a light touch is needed. The idea is to simply take a raking pick and repetitively pull it across all the pins in such a fashion as to push the pins upward and unlock the pin tumbler. Make sure you apply a continuous, gentle force to all of the pins as you rake them. Don't skip any. While this may sound too simple at first, it can work well if done properly. Your first pass will most likely not be successful. You must make many passes. With each pass of the pick, slightly increase the turning force on the torque wrench. As frustration sets in, people have a tendency to apply too much force. This won't work. It only leads to more frustration. Different rakes and styles of raking work better for different styles of locks. Experience and practice will show you which ones work best. Some require quick, light movements, while others take slow, stronger passes. Remember to use a variety of practice locks to get comfortable with various techniques. Another method you can use is to set each pin individually. You have to understand more about the inner workings of the lock, but the knowledge will help you greatly. As always, your goal is to clear the shear line of any obstructing pins so the plug may rotate. If locks were perfectly manufactured, it would be impossible to pick individual pins. But in the real world, locks have many imperfections and are built to affordable tolerances. The better the tolerances, the better the lock, the more it will cost. Metal pieces have to slide and rotate by each other, so there must be small gaps to make this motion possible. The first aspect we are going to look at is called binding. This occurs when the plug tries to rotate and crimps a pin against the hull, holding it in place. When this happens, you will no longer be able to rotate the plug, since the pin is being held in the way. The holes drilled in real locks will not line up in an exact line. Because of this, when you rotate the plug, one of the pins will bind first, while the others are left loose. Since each lock is different, each lock's pins will bind in a different order. If you rotate the plug in the other direction, the pins will bind in the opposite order. First, use your pick to determine which pin is binding the most. Then push up on that pin until the top pin is completely inside the hull. The top pin that used to be crimped between the hull and the plug is now no longer in the way. So the plug will rotate slightly until it crimps another pin stack. You should be able to hear or feel this slight movement with your torque wrench. The top pin is now trapped and will rest on the top of the plug while the bottom pin is free to fall downward. This is called setting the pin. You are now ready to move on to the next pin column that is now binding. When you are pushing up on the pins, be careful to stop at just the right point when they set. If you push too far, the bottom pin will continue and move into the hull as well. The plug and hull will now bind the bottom pin, which will keep you from rotating the plug. You can tell if this happens when you remove your pick and the bottom pin neither springs down nor free falls down. Simply reduce the pressure on your torque wrench until the pin falls down. Several other pins you had previously set may also fall when doing this, so be careful. You can also try picking the pins in a different order to make things easier. Now it's your turn to start picking pin tumblers. First, insert a torque wrench into the keyway. Apply a gentle turning pressure with the turning tool. Again, the word gentle is emphasized. If too many pins bind, they will jam too tightly. If the pins that do bind are too difficult to push up, then you are turning too hard. When you become frustrated and tired, you will likely start turning harder. When this happens, take a break and recover. Well-machined locks and those made to tighter tolerances will require the use of more torque. Padlocks and some doorknobs also have to turn a spring-loaded locking bolt, so these require more torque. Experience will tell you how much torque to apply. When you pick padlocks, there is the additional skill of holding the lock in the same hand that you use to turn the wrench. With practice, you will learn which method suits you best. Try a variety of methods. Remember, this isn't always an exact science. While you are applying this gentle turning pressure, use the pick to feel the pins. Don't use your sight, just feel them. By knowing how they respond in various situations, you can create an internal map in your mind of what the lock looks like and the state of all the pins. Remember to visualize. This is a critical skill to learn. Just as many athletes try to visualize before a game what they will have to perform, so should you visualize yourself how you will pick the lock. Next, attempt to determine which pin is binding the most. Then, position your pick directly under it and use the tip of your pick to make contact with the bottom of the pin. Apply a small amount of force, pushing the pin upward in your attempt to push the top pin completely into the upper chamber of the lock. Be certain not to disturb the neighboring pins too much during this process. There are a variety of hook pick sizes that are better for different shaped locks. Also, you can use any other type of pick or rake that works well for you. Remember, the only rule is to use what works. When the top pin completely clears the shear line and enters the hull, you will have set the pin. This is also called breaking the pin. When this happens, you will hear or feel a small click. When your senses are in tune with this, it will become an earth-shattering event. You will feel the pin respond differently. At first, you had to fight against both the top pin binding and the spring pushing down. For a brief moment, in the gap, there will be just the spring resisting you. Then there will be a large resistance as the bottom pin hits the edge of the hole in the hull. You must get used to how this feels. You will also feel the click in the hand that is holding the torque wrench. The wrench will give and the plug will rotate ever so slightly and then stop. Although you can feel this, you probably won't be able to see it. Treat the tools as extensions of your body. Don't trust your eyes. Use your other senses to experience the lock. After you have set the pin, lower your pick and make sure that the bottom pin falls down freely. If it stays up, then you have pushed the pin up too far. You can either relieve some tension from the wrench in order to let it drop or start over. If the spring pushes the pin down, then you haven't set it yet. Perhaps this pin isn't the one binding the most, or you didn't push up far enough, or you didn't apply enough torque to the wrench. When the last pin is set, the shear line will be clear with no obstructions, and the plug will be free to rotate. The lock is now open. The actual mechanics behind each lock that unlocks, freezes, or opens vary greatly. Padlocks usually have to actuate a spring-loaded locking bolt in order to release the shackle. This means that you will need to apply a little more torque to get them to open. Shimming is another method of bypassing a lock. The idea is to insert some sort of object into the locking mechanism and move the locking bolt, or whatever is holding the shackle inside the lock, out of the way. Since the mechanisms vary greatly, there is no standard method for shimming a lock. Shimming can also be effective on a wide variety of padlocks. Padlocks usually work by having a spring-loaded locking bolt fit into a notch in the shackle in order to hold it inside the lock. Often the locking bolt will have an angled top, which allows the shackle to be closed without unlocking the lock. This means that the locking bolt must be spring-loaded. So, if you can fit a very thin, strong object into the lock parallel to the shackle, you can sometimes slide the locking bolt out of the way and spring the shackle open. This requires that the lock's hole for the shackle is large enough to also allow for the shimming tool to fit inside. This method will also work for warded padlocks. The actual lock type is almost irrelevant. Padlock shims are often sold that are specifically made to help you deal with padlocks with less hassle. They are made of thin yet strong material that can be inserted into the padlock and then rotated to release the latch. They are often tapered to make them much easier with which to work. Shimming is also very effective on common doorknobs. The latch is the portion of the locking bolt mechanism that sticks out of the door into the door jamb and holds the door shut. One side of the latch is angled so that the door can be closed without turning the handle. This is because it is spring-loaded. All you need to do is to take a tool and stick it in the gap between the door jamb and the door. You may have heard about credit cards being used for this. Try not to break your card if you attempt to use it for this purpose. Most latches will have springs that are too strong and will require a stronger, different shaped, or better tool for this purpose. Make contact with the bolt and work it back into the door, and the door will open. Some door jambs are better than others at blocking access to the door's latch. Many sophisticated doorknob assemblies used in commercial applications are not susceptible to this. They have additional protrusions that stick out of the door. This anti-pick latch is pushed into the door when the door is closed. The mechanism then mechanically prevents the main latch from being pushed back into the door without opening the lock. Sometimes you don't have to pick the lock at all in order to open it. You can merely bypass it. This is called bypass picking. It requires that the lock allows for it. Therefore, this method only works on lighter security locks that have an exposed locking bolt in the rear of the keyway or elsewhere. Many desks, cabinets, and a few padlocks are like this. The concept is simple. Insert your bypass pick all the way into the lock and ignore the pins or wafers completely. Attempt to move the locking bolt manually with your tool. Whatever the lock would have done if unlocked, you should try to do the same thing to the bolt. You may be able to move it out of the shackle or slot and allow the lock to open. It is a simple concept when you are lucky enough to have a lock that allows this. When done properly, impact picking and vibration picking can be one of the fastest ways to open a lock. These methods are also beneficial because they require less skill. These methods work on most pin tumblers. Law enforcement officers or other professionals who must open locks in emergencies when time is critical will use this method. They may often have other issues to worry about and do not have the time or inclination to learn the more subtle aspects of the art of lockpicking. You can generally pick up the right tool and use it effectively after some experimentation. Experience is still very important for you to have the right touch. These tools do require, though, a lock that is susceptible to these methods. You will need to have an appropriate pick gun. This is a tool you hold in one hand that usually has a lever or trigger that you squeeze with your fingers to provide a vibrating or snapping action. Remember that you still need to use a torque wrench with these devices. Place the pick gun all the way into the keyway. Insert the torque wrench, applying a rotating pressure on the wrench, and squeeze the trigger. Do not move the gun vertically or laterally while picking. As the pick strikes the pins and knocks them upward, use your torque wrench to cause the plug to catch the top pins as they jump into the hole casing. This method uses a snapping motion. A flat tool accelerates toward the pins and strikes them all simultaneously. The physics is similar to billiard balls or those desk toys that have one marble swing and hit a second. The momentum from the first ball is completely absorbed and passed to the second, which moves on roughly with the same speed, leaving the first ball in place. This is what the impact attempts to do. It impacts the tips of the bottom pins with just enough force to knock them into the top pins, thus knocking the top pins up into the hull. The lower pins themselves hopefully stay down, because they imparted all of their energy into the top pins. You really don't have to know all of this theory to effectively use a vibration or impact tool. Just put it in the keyway, pull the trigger, and rotate your torque wrench at just the right time. You must be sure to make contact with each of the pins. When using an impact tool, make certain that you impact the center of each of the pins exactly straight on and at the same time. This means the blade must be exactly parallel to the keyway. Some tools have angled blades to allow holding the tool at an angle if space is tight. These will require a bit more practice to ensure that the blade is always parallel and strikes all pins simultaneously. Different locks will require a different amount of force for their pins to bounce properly. The locks must also be in good working order. If the lock is dirty, the pins may be unable to bounce freely inside their chambers. Chapter 3. Advanced Pin Tumblers, Rounded and Beveled, Master Keyed, and High Security Pins. Most locks you will encounter have to be affordable. Therefore, they will also be easier to pick. Manufacturers are always looking for new and innovative ways to make locks more secure. They are also looking for ways to make them cheaper. Because of this, you will encounter many modifications Some will make your job easier, some harder. Higher quality locks are made to tighter tolerances. Picking these more expensive devices can be a challenging task that will demand more practice. Advanced lock picking is an art that requires you to be in tune with yourself and the lock to pick up minute movements in the lock. There is less room for error, and it will be harder to tell when the pins are set. Of course, sometimes the manufacturer will try to trick you by using different types of pins or holes. The ends of the pins that meet at the shear line are usually mostly flat. The key must lift them to the correct height to allow the plug to turn. Sometimes, though, this is not the case. These ends can be rounded, either to account for lower tolerances or to portray a false set. That is, the plug can rotate slightly, giving the effect as if it were set, even though it is still jammed in place. Loosen your torque slightly and try to jiggle the pins into place. Here, the bottom pins have a rounded top and can problematically jam slightly beyond the shear line. You have to stop pushing up on the pin exactly as it sets, or the rounded end can enter the hull. This will keep the plug from rotating. However, it will still turn some, and another pin column may begin to bind. Just loosen your torque and allow the pin to fall, or use your pick to jiggle it loose. Again, you may lose some other pins you had previously set, so you'll have to be careful and do them over again. Beveled holes can cause a similar problem. They can also work in conjunction with each other to make your job easier or more difficult. The pins can also get stuck on the bevel in the hole and cause another false set that mimics the reaction of a real set. Here we can see the pins being raised and the top pin jamming on the hole's bevel. You may have to rake over the pins a few more times or pick some of the pins a few times in order to get a lock with beveled holes and rounded pins to open. Depending on the design, though, your job could be easier and the pins could slide into place with less effort. Ultimately, your persistence will pay off. Many installations and buildings have a large number of different locks that each need their own key. For example, each room in a hotel needs a different lock for each door. It would not be practical, though, for owners or maintenance personnel to carry that many keys. So there is usually one master key that can unlock all of the doors in a system. Picking these locks can actually be easier, however, since there are more pin combinations that can open each lock. These locks have extra middle pins in some stacks that allow them to rise to different heights, yet still break at the shear line. This allows two different keys with one or more notches cut to the correct second height to also work the lock. Usually the master key will lift the bottom pin to the shear line, while the user key lifts the middle pin to the shear line. This means the master key will have the shallower cut. Otherwise, someone could simply file down the correct notch on a user key to make a master key that could open all of the locks in the system. As you can see, there are more pin height possibilities, and you are more likely to get one right when you try to pick a lock that supports a master key. The more middle pins, the more keys a lock will work with. Thus, it is easier to pick. There may even be unintended combinations for which there are no keys. Often, to compensate for the middle pins making picking easier, some of the normal pins will be replaced with special high-security pins. High-security pins are almost the same as normal pins. They serve the same basic purpose. They move up and down in the pin stack and separate at the shear line, just like their simpler brethren. They only begin to act differently when someone tries to pick them. These more costly pins will fool you into thinking you have set them, while they haven't really cleared the shear line at all. You will get that satisfying click and the plug will rotate just like normal. But something is amiss. The lock will refuse to open. The mushroom pin gets its name because its shape vaguely resembles a mushroom. The indentation in the side of the pin allows it to false set as it is being pushed upwards. The top edge of the head of the pin will slip by, mimicking the pin setting, yet remain stuck at the same time. Because it is the top pin that is set, the lower pin can still fall freely down, further maintaining the charade. Because it is the top of the pin that is stuck, you can no longer simply continue to push up. You will have to slightly release your pressure on the torque wrench, while tapping or pushing up to allow the pin to fit completely through the hole. Especially if they have rounded ends, you may have to pick some pins several times for them to properly set. This backwards rotation of the plug will provide valuable feedback, though it may unset some pins you had previously set. Don't worry, you will be able to go back and pick those normal pins again later. A second popular design for high-security pins is the spool pin. They are also aptly named because their shape resembles a spool. They produce a very deceiving false set and can be difficult to detect until too late. The side of the pin is designed to catch on the edge of the hole, making it very difficult to push up while applying too much torque. Again, try to reduce your torque and jiggle up on the deceiving pin. An important difference between opening a lock with a key and picking it is that torque must be applied to the plug while picking. A special pin design called a serrated pin exploits this fact to make picking incredibly difficult. The sides of the pin and hole have teeth and edges that catch on each other when torque is applied to the plug. This holds them in place and prevents you from pushing them upwards. Vibrational or impact methods may work better for these locks. Generally, only a few of the top pins will be replaced with these special high-security pins, though the serrated design may be used in all of the pin columns. If pushing up on a pin causes the plug to rotate backwards slightly, then you are most likely dealing with a security pin. A light torque with a heavier picking force can be used, or you can switch to a high-speed raking, impact, or vibrational method. Security tumblers were once the exclusive domain of expensive, high-security cylinders. As time goes by, they are becoming more and more common. You are probably quite likely to experience them in your travels, but not on the common door lock yet. Chapter 4, Wafer Locks, How They Work and How to Pick Them. The wafer lock is very common in many low-cost applications since they are much cheaper to manufacture. They can be found everywhere, including desks, filing cabinets, doors, windows, security boxes, etc. They are very similar to pin tumblers, except they use wafers instead of pins. The easiest way to identify one is by noticing the flat wafer in the keyway in place of a round pin. Picking them is almost identical and usually much easier. The internal workings of a wafer lock, however, are quite different. Wafer locks work by utilizing wafers that rise or lower inside the plug. If they move too high or too low, they will protrude out of the plug, locking it in place and preventing it from rotating. The wafers are cut differently, so they have to be moved to a different height so that they protrude. With the correct key, the wafers will move to the correct height and nothing will protrude from the plug. It will be free to rotate. In an attempt to increase their security, manufacturers have developed the double-sided wafer lock. The wafers have alternating springs, so some will have to be pushed up, while others need to be pushed down. Their keys are quite distinguishable because they have notches on both sides and may be inserted in either direction. Here is where your set of double-sided picks will come in handy. You can push up on the top of the lock and then push down on the bottom of the lock without having to take out your pick and turn it over. If you already have learned about single-sided wafer locks, then double-sided ones are a straightforward extension of what you already know. This special dual-pronged torque wrench, pictured here, is common in many kits and works great for double-sided locks, since you can insert your pick in the middle and easily access both the top and bottom of the wafers. When picking wafer locks, you can use most of the same techniques as with pin tumblers, with the exception of impact and vibration techniques. Due to their nature, some special tools were developed specifically for these locks. One such tool is the tryout key. A locksmith might have a large collection of such keys, which more or less resemble actual keys. They vary in size and shape in the hope that, if one doesn't work, the next one might. If lock tolerances are poor, tryout key makers can cut a notch between two depths, and it should work for both. In fact, before 1968, a set of only around 64 tryout keys could open any GM automotive lock. They're simple to use. Insert the key, jiggle it around slightly, and work it in and out while trying to turn the lock. If it doesn't work, move on to the next key. With just the right touch, with cheaper locks, and with luck, you can be very successful with this method. With experience, you will find wafer locks are usually easier to pick than their pin tumbler equivalents. What will help you most, though, is practice. In time, you will be able to pick or bypass most common locks that are encountered in everyday life. We hope you enjoyed this educational video. Remember to keep practicing to build your skills. Lock picking is an art that you can develop over time. Also be sure to follow all applicable laws for your area regarding the possession and use of lock picks and lock picking tools. One of the best ways to learn this art is to apprentice with an experienced locksmith. You will learn there is a lot more to being a locksmith than just picking locks. Again, we hope you enjoyed this video and keep practicing.